Alright, so yesterday we left off on 3.1, and we did not finish example 3 with the word problems, but we finished the ratio tables, and y'all did really good cross multiplying and dividing. Okay, we're going to look at the second word problem, because when I went to look at the first word problem, I kind of accidentally left off some important information, so we can't really do that right now. So we're going to do number 2. It says a city dumps plastic shade balls into a reservoir to prevent water from evaporating during a drought. It costs $5,760 for 16,000 shade balls. How much does it cost for 12,000 shade balls? How are we going to attack this problem? What are we going to do?
It'll do 5,760 over 60.
Okay, do we have ratios? What's the definition of a ratio?
Division. Or
Go back to the first page of your notes. Very first page, at the very front. It tells you.
it describes the multiplication.
Alright, a ratio is a comparison of two quantities or two things. Are we comparing two things here? Do we have two different things assigned a number? Yeah. I have money, cost, and I have the shade balls. Do y'all know what these are? The shade balls? So they're like these plastic balls that they can put out on the water and they float on the water. It basically shades or protects the water from the sun so that the sun can't evaporate the water. It's pretty cool. Ask Gavin, he knows all about it. Apparently.
Oh, jump.
Alright, so we've got two different things. So we can make a ratio of this. What comes first in the sentence or the problem?
The 5,760.
The money, right? Money comes first, and then comes the shade balls, right? That's the order in which they're writing the ratio. In order to solve ratios, we're going to need to write them in fraction form. To find the values, we got to have fractions. So how can I turn money to balls into a fraction? What's going to go in the numerator?
500. Yeah.
We're talking about the labels. We're talking about the labels for a second, not the numbers. The labels. What label is going to go in the numerator?
Money.
Money. And that's going to go in the denominator. So when I make my ratio box, y'all are good at solving ratio boxes. It's just sometimes you don't take the time to label them, and then you put the numbers in the wrong spot, and you get confused. So put the labels. Okay? It's not going to take you that much more time. So I've got money to balls, money to balls. And I'm just going to go ahead and side note this. It's kind of like a little tip. When you're doing rates that involve money, it's always money over number. Money's always on top. Okay? I might want to write something like that down. Money's always on top. Money's always going to go on top. The number's always going to go on the bottom. Number on top, money on bottom. I mean, money on top, sorry, number on bottom. Whoop, mixed up in the head. When you're talking, when you have something that involves time, time is always on the bottom, and the number is always on the top. Think about when you're talking about the speed, miles per hour. The hour comes last. Okay, that's just a little tidbit. Those are the most common rates you're going to see are money and time. So just as a reminder. Okay, so the first column is our original ratio. How much money are we dealing with?
5,760.
Okay, with 16,000 shade balls. The second column is our question column. It says how much does it cost? Do we know how much it costs? No, that's our missing value. Do we know how many balls we have? 12,000. And so to solve for x, what process do we have to go through?
Multiplication and division.
Cross multiply
Cross product.
5,760 times 12,000 divided by 16,000, which gives me a grand total of
4,320. Couldn't you just do like a fraction?
4,320.
Couldn't you just do a fraction like 5,760 divided by 16,000 and then multiply it by 12,000? 12 for the 12,000.
You tell me, does it work?
Yeah, I got 4,320.
Alright, so what Eli was saying, I don't know if you heard this or not. He found the value of the ratio first. He found the unit rate. He did this. Okay. Which gives you, put that in your, gives you what? 0.36. That's the value or the unit rate. You can take that value and multiply it by 12,000, test it to see. What do you get?
1,320.
So those are two options that you have. You have the option of a ratio box, or you have the option of using the value and multiplying it by whatever number you have. Okay? This right here, this value part, is how we used to do ratios back in my day. And sometimes it would get a little confusing. Okay? Then I learned how to do ratio boxes, and it organizes everything and makes everything nice and neat. So I choose to use ratio boxes. You can use whichever way, they both work. Okay? Alright, an oil spill spreads 25 square meters every 1/6 hour. What is the area of the oil spill after 2 hours? So is this a ratio?
Yes.
Well, it's comparing two things. And what are the two things it's comparing?
45 square meters and 160.
Meters and hours. So I've got meters compared to hours. I've got 25 meters and 1/6 of an hour. So when I make my ratio box, I want my meters first because it comes first in the ratio. And I want my hours on the bottom, back to where time is on the bottom. Whatever I label on one side, I need to label on the other. My original ratio was 25 to 1/6. The second column comes from the question. The question says, what is the area? We don't know. We don't know how many meters after 2 hours. And then you solve. Cross multiply and divide. And what do you get?
30. Over 50. No.
300.
You should have gotten 300.
You really said 50?
You should have got 300. So let's test to see if the value of the ratio works as well. Can I take 25 over 1/6, and what do I get? 25 over 1/6 gives me what?
150.
What is it?
150.
150. Okay, I'm supposed to take that value now and multiply it by the number, and it gives me 300. So you get the same answer, just a different way.
Wait,
What does that 300 represent? 300 what?
300 or
Meters,
square
300 meters.
Alright,
for every
300 per, not per hour, per
1/6. 2 hours.
2 hours. Because your new ratio, this rate, would be 300 to 2. Your unit rate was 150 per hour. Okay, good. All right. All right, turn it to 5.2. 5.2 is about the exact same. You're using unit rates and rates to solve problems. Okay? A rate is a ratio. A unit rate is written R first, then 1. It's the rate of 1. So example 1 says a nutrition label shows that 1/4 cup of tuna has 1/2 gram of fat. How many grams of fat are there for every cup of tuna? This is where the order matters. Okay? Look at the question part. What part of the ratio do they want to come first?
Graham.
They want grams of fat first, 2 cups of tuna. So they want fat to tuna. So when I make my ratio box, I'm going to make it fat to tuna. Fat to tuna. How much in my original ratio, how much fat was there? 1/2 of a gram. How much tuna was there? 1/4 of a cup. If I look at the question part, it says how many grams of fat? Well, that's the part we're finding. We don't know. For every cup of tuna. But I don't have a number.
Should be 1.
How do you know it's 1?
Because it says
It's
for every cup.
For every cup. Okay?
See that?
It's singular, which means it's 1. We also talked about how it's going to look like this. Okay? Which means as a fraction, the rate's going to be up top and the 1's going to be on the bottom. Our number's going to be on the top, the 1's going to be on the bottom. Okay? So we can cross multiply and divide.
Get 2.
And so there's going to be 2 grams of fat
For every cup
for every 1 cup
of tuna.
tuna.
Is that right, tuna? It's good.
I like tuna salad. Get it in a can, then you drain the juice, put some mayo in it, put some relish in it, then some crackers. It's real good.
Noodles.
That does not sound
I've never
good.
had like tuna. And then
Alright.
put sprinkles in it.
Let's go back. Alright, look at part B. They swap it on us. It says, how many cups of tuna are there for every gram of fat? How many cups of tuna are there for every gram of fat? What's the order of the ratio now?
It's swapped.
It's swapped. They want tuna first, then they want the fat. So it's swapped. Okay, so I've got tuna to fat, tuna to fat. So I have 1/4 cup of tuna for every 1/2 gram of fat. I don't know how many tunas, but it's for every gram, singular being 1. So when I cross multiply and divide,
1/2.
there's 1/2 cups of tuna for every
Gram of fat.
gram of fat. Are we okay so far? It's pretty straightforward, pretty easy. Alright, there is 1/4 gram of fat for every 1/3 tablespoon of powdered peanut butter. That's tongue twister, powdered peanut butter. How many grams of fat are there for every tablespoon of powder? You try it right before you pick up your calculator. Write something down before you put in something in the calculator. How many grams of fat are there for every tablespoon of powder?
I wrote something down. Thank you, Cole.
Okay? So what order did you do yours in? What order of ratio did you make?
1/4,
1/4, 1/3.
You did, thank you. You did fat first, and then powdered, ooh, that's a B, not a P. You did powdered peanut butter. Anybody ever had powdered peanut butter before?
Sounds good.
Yes.
Alright, so I have 1/4 fat to 1/3 of a powdered peanut butter. So when I put it in the ratio, I have fat to powdered peanut butter. Fat to powdered peanut butter. It's kind of fun to say when you say it like that.
Powdered peanut butter.
Okay. We don't know how many grams of fat for every tablespoon, meaning singular, which tells me I'm finding the unit rate. So it's R to 1. So after I cross multiply and I divide, what do I get?
3/4. Positive.
3/4 grams of fat. Bravo. Okay, alright. The directions say find the unit rate. So remember, when you're finding the unit rate, it's R to 1. So like, we're comparing in number 9, we're comparing miles to hours. So miles to hours. So I have 180 miles in 3 hours. I don't know how many miles I can go, but I'm looking for 1 hour. That 1 is always going to go in that bottom. It's always the second thing you're comparing. So you can wrap a pretty little box around it to make you comfortable if you want. Or you can just cross multiply and divide. And what do you get as your unit rate? X equals 60. So what that means is I can go 60 miles per 1 hour. 60 miles per hour. That's how you calculate speed. Speed is distance over time. At some point in your life, probably next year, you're going to learn what's called the DIRT formula. D equals RT. You can put a little I right there, and it spells dirt. Okay? D represents distance, how far you're going. R is rate or speed, like how fast. And T stands for, can you guess? Time. So let's say I'm trying to find the rate, the unit rate. I'm trying to find the speed or the rate. What do I have to move to get the rate all by itself? The T. Well, to move the T, I have to do the opposite operations like we learned in the last chapter. Right now it's multiplication, so to move it I'd have to do, so I'd have to do distance over time. I did miles over hours. Distance over time. Let's say I want to find time. So I've got the dirt formula, and I want to find time. Where do I have to move?
D. No, R.
I'm looking for T, and I want T by itself. So what do I have to move?
R.
I have to move the R over using what operation?
Division.
So in order to find the time it's going to take, so like let's say you're, like this is what your GPS does to calculate how long it's going to take for me to get from here to Disney World. It tells me it's this many miles to Disney World. She's going 80 miles an hour. How long is it going to take? I'm on the interstate. Okay. It's okay. It happens. Maybe you shouldn't go 80 maybe, but I mean nobody's going to, anyway. We're not going on that. Alright, so it's going to calculate and tell me, well, how long is it going to take? Well, if I'm going 80, it's going to take this many hours. But if I'm being grandma and only going 55 miles an hour, it's going to take a lot longer, right? That's how your GPS figures out what time, how long it's going to take you to get there. Okay? Dirt formula is really important. You can remember dirt. You can figure out a bunch of different things. You use this in physical science and physics and things like that. Kind of cool. I would never remember this formula unless my teacher had taught me as dirt. I was like, oh, I can remember that. Anyways, all right, so find the unit rate of those 4 problems. I know some people already started. But find the unit rate for each one of those. All right. What do we get as the unit rate for number 10?
32.
32 what?
32. Yeah.
Miles per
miles.
gallon. Where do we see miles per gallon at?
How many miles per gallon you get?
Yeah. So like in my car, when I'm driving from here to Warner Robins, I've got this little fuel efficiency gauge, and like if I'm driving like I'm supposed to and nice and smooth and using my cruise and stuff, I get better mileage, gas mileage. But if I'm like having to slam on brakes a lot or traffic's really bad and you're stopping and starting and things, then your gas mileage is not going to be as great. So 32 miles per gallon is pretty good. All right, number 11, pound per days. How many pounds can you make in a day?
110.
1/10 of a pound.
1/10 of a pound per day.
Okay, so basically,
Okay? Number 12, grams to servings.
I get 16 thirds. 16 thirds.
16 thirds. All right, and then number 13.
You get
2.4,
$2.40.
$2.40.
All right, so because you're talking about money, it's not just 2.4. Money has how many decimal places?
2.
2. So I've got 1. I have to add another. What can I add behind the
Zero.
a 0? So $2.40 per pound. That's what you see on the labels at the grocery store. Like if you go over to the meat section, and it's got the label. It's got the price per ounce or per pound, and then it's got the total. This is how they get that. Okay? Alright, this is a fun one. I want to see, there's a little trickery in this one. I want to see if you can figure it out. So, try that one, and see if you can find the trickery. Find the trickery. Find it on the paper.
One two multiply 24 times 1.5 hours. I think I got it.
Got it.
I think I got it. It was a big brain like that.
They didn't fall for the trickery. Good, good.
I'm smart like that.
Oh, 18.
Ooh.
Caroline didn't fall for the trickery. You fell for the trickery. You fell for the trickery.
Yes.
Trickery. You fell for nothing. That's nowhere, right?
Oh, John. What? Wait.
Good. Good. My lady's over here killing it.
I don't get this.
Hey, Kate Keelan got it.
So that means it has to be this.
All right, so let's look. What are the two things you're comparing here in your ratio?
Time and distance.
Time and distance. Okay? So we've got feet to hours. All right, so I'll start making my ratio box like several of you did. I got feet to hours, feet to hours. I've got 9 feet in half an hour. And then I look at the question, how far does the liquid iron travel in 1 day? We're talking about
Like 24.
hours. Well, how many hours are in a day?
24.
24.
Oh.
If it helps you feel any better, when I did this initially by myself, I did not do the 24 because I was not paying attention. So, I fell for the trickery first too. So, just So you know.
I did it 24 times.
So you
one
should have
day.
gotten 432
Did it.
feet.
You barely did it.
It's not close.
That was what you got.
It's like,
What?
I was like, did you get this?
Okay.
I was like, what? No.
We're gonna skip the first one and come back to it if we have time. I want you to try the second and the third one.
I'm about to fall for it.
Don't fall for trickeries and things like that.
Are there trickeries?
I don't know.
I'm just smart like that. I won't.
I don't know. Pay attention. Alright, because I don't want us to run out of time. So, that second one could be a little bit tricky. How many of you use ratio boxes? Okay, that's what I used. So, I've got person A, okay, and we're comparing miles to seconds. And their rate is 1/10 of a mile for every 15 seconds. We're going a 5-mile race.
Ooh, I didn't see that.
We're going a 5-mile race. We need to know how long is it going to take us, because it's a race, and races are based off of time, right? So when I cross multiply and I divide, I get 750 seconds. Person B, same setup, miles to seconds. You go 3/8 of a mile in 48 seconds. And they're also going 5 miles. It takes them 640 seconds. Who wins the race, A or B?
B.
A. Oh wait,
B.
B, no.
So when you're talking about a race, you kind of have to think about it backwards, because when you're racing, you want the lowest time, right? So person B actually wins. If you did it as a unit rate, person A's unit rate was 1/150, and person B's unit rate was 1/128. Who has the greatest unit rate? Who's going to cover the most distance?
A. Oh no, B.
Remember, in a fraction, the bigger the denominator, the tinier the pieces get. So this fraction is actually bigger, meaning he's going to cover more distance in the same amount of time. Okay? So person B. And then your second one, you should have gotten
5/72. Huh? That's what I got.
I got, not that. Alright, I got yards. I did yards over hours. Okay, I got 4/9 of a yard in half an hour. If I do 3.2 hours, when I cross multiplied and divided, I got 2.84 repeating. Did anybody else get that? Okay, y'all make me think I was going crazy for a second.
I put instead of 3.2, I put 16/5. Because then I went to decimal and fractions.
That's fine, but
So if I were to turn,
So like
so turn your fraction into a decimal and see what you get. All right, we will do some practice tomorrow. We'll probably do this, if you will do this one tonight with your work, show your work, and you have it right, I'll have candy for you tomorrow.
Oh yeah.